All right, so today we are going to learn about Python. And so quick fun question. Does anyone know what Python was named after?
Monty Python and the Search for
Monty
the Holy Grail, right?
Yes, it was named after the movie Monty Python and Search for the Holy Grail. If you haven't seen it, it's a work of art. It's hilarious, and you should. And if you don't like it, don't judge me for liking it. Awesome. So in Python, like all programming languages, we'll manipulate different data types, like numbers and lists. And if you want to understand how you can manipulate data and compare it to other data, the most important thing to understand is the type of your data. So many of these data types are similar to the ones that we used in JavaScript, but some of the most important differences I'll point out, and there's two different types, primitive types, which are a single value like Benjamin talked about yesterday, and non-primitive types, which can contain other data types. So let's start off with an example with some primitive types. Okay. So primitive types, we know numbers. So a small number is 4. If you want to know what type something is, you can print. So equivalent to the console log that we have in JavaScript, print is going to be what prints something to the console or to the terminal when we run it. So if we want to print a small number, we can do this. Let me go into, okay, let me go into this week's code. And you can just run it using Python. I don't think I have my aliases up, so Python regular will not work for me. So if I do Python, it won't find the command. I have to do Python 3. I should probably set that up, but I think it's a good learning thing to show. Okay, so we ran our code, we got 4. Let me try showing you what type it is. So type, and it'll tell you it's of type int. So this is just a regular integer. Let's see what happens if I add 0.5. Now it's of type float. So in numbers, you have ints, floats. I forgot what other types of, let's see. I think we can do the E notation as well. That is also of type float. Yeah, so just boring old numbers. So in Python, unlike JavaScript, we don't have to use a let or a constant to define a variable. So we can just say the variable's name, assign it to whatever value we want to assign it to, and that's it. So when we choose a name, we typically do snake case, like I mentioned earlier, and this is snake case. So each word is separated by an underscore, and it's just a very common convention that you will see. Yeah, so we see the type of this variable. With numbers, similar to JavaScript, you can do all the operations. So like plus, minus, multiply, the comparison operators, all those things. I'm not really going to go into them because we've seen them with JavaScript, but it's pretty much the same. The only thing is a small number. There is no 3 equal signs to compare to things. So it would be equal, 4, it should print out false. Awesome. Okay, so when you're comparing, you just use two. That's pretty much it. So these are numbers. Strings are also pretty similar to JavaScript. You can use either a single or double quote. So let's say name. Oops. Let's say name is Zainab. And another name. Someone's name. So you've seen this yesterday. If you want to put an apostrophe inside of double quotes, that is fine. But if you have a singular quote in this, it won't work. So to escape the character or to allow it to be inside of that string, you can do the backslash. I think backslash before it. Yeah. So you do the backslash to basically tell Python, this is going to be a special character. I know it's not usually allowed, but for this time, allow it because I'm telling you to. So with this, if we print out another name, now it just prints out the actual string as it is. What else? Python also supports string interpolation. So basically being able to input a variable inside of a string. So let's say I have a string today. Let's say this person wants to hang out with this person. So all you have to do is put the curly braces, another name, and you see it's still in red. That means it's not correct at the moment. So if you want to format a string in a certain way, you want to add an F for formatting. And you see now these are colored as parentheses and then the variables inside of them. So if I print this out, you'll see that it inserted the names inside of where I put the variables here. In Python, we can also add strings. I'm pretty sure JavaScript can do the same. So if I say name plus space plus another name, and I print that out, it adds it into the same string. Awesome. And the last type of primitive type is Booleans. So in Python, we have capital case true and capital case false. So I'll explain that one later. But yeah, you can do true and you can do false with capitals, same way, just spelled a little differently. Awesome. Any questions? I know this is very basic stuff. Please.
Yeah, is it creating another string or is it adding to it?
For this one?
Yes.
This one is creating a new string.
Okay.
So I can say new string equals this. Let me use the fancy moving command and then new string. Yeah. So it creates a new string and then you can assign it to a variable if you'd like. Any other questions?
Yeah, I had a question about the double equals.
Mhm.
Does it work just like the triple equals in JavaScript?
It does.
Okay, so so it's gonna tell you if it's the same type of object, right?
Mhm.
Okay.
Yeah, it's going to compare the value and type as well. Yeah. Yeah, in Python, there's no such thing as like a string for being equal to the number 4. So any other questions?
Yeah, can you, sorry if I missed it, can you reassign the variables as well?
Yeah, definitely. So another name equals, I guess I can do it down here so we can see. Oops. Let's say, okay. So if I run it, we see the first one was the other name, and then the second print was using the new name. But yeah, you can reassign all the variables. Other questions? And good questions, guys. Thank you. All right. Okay, so let's now talk about non-primitive types. What's an example of a non-primitive type? What do you think is the simplest example that you can think of?
Array.
Yeah. So in Python, we call them lists instead of arrays, but it is pretty much the same thing. So
Dictionaries.
dictionaries are also, yeah. We'll talk about those right after. Actually, we'll talk about one more after this, but yeah, so we'll start off with lists. Lists are similar to JavaScript arrays. You can define them using the square brackets. So my new list is this, and you can just define it like this. If you would like to append to a list, so add items to a list, you would say my new list dot append, and then you can add whatever you want. So I can add like a number, let's say, and then I can do the same thing, append, and you should be able to add anything you want. I don't think you need to have the same types, and we can test it out. So we can just try to print my new list, and I'll print out berries as well. For these, I'm just going to comment the print statements out so our terminal doesn't get too busy. Awesome. Just gonna do a little line. Okay, so let's run this. And here we go. We got this list, and then we got the second list. So if we want to try to see what type it is, the type will be list. There we go. Of course, class called list. There's a few things that you can do with these lists. You can access certain variables. Access certain indices. So how can I access, let's say, the first index? Anyone who might know?
The name of the array, then brackets, 0.
Yep. So you can access indices using, this one out, using the index number. So it always starts from 0, 0, 1, 2, and so on. You can also do print berries at -1, and -1 will give you the end of the list. So it gave us pumpkin. Pumpkin is at the end. Let's see what else. We can do a slice of the array. So we can tell it to grab. Let's say we want to grab like these three elements here. So it's going to be index 2 through index 3, 4. So let's try that. So to do that, you do the starting index and then a colon and then the end index. And we can print it out. This actually gave us ending index not included. So 0, 1, 2. So it started at cucumber, went to 3, and then it stopped at 3 right before 4. So it didn't include the banana variable. So if I wanted to include that as well, I can increase this to 5. And there we go. We got these 3. You can also do something similar with this. So if I want to do berries at, let's say I want to grab from the start to index 3. So 0 and 2, so just the first 3 elements. I don't have to specify the start index. I can just put a colon and then I can put 3. And if I print it out, it gives me the first 3 elements here. And you can do the same thing if you want to do the end. So let's say I want to start at index 3 and I want to print all the way to the end. So I just put a colon afterwards. And then that takes it from index 3 all the way to the end. Awesome. Any questions about this?
Yeah, I got one. How do you remove and add to the list?
So to add to the list, you use append. So if I wanted to say berries.append, strawberries. Funny because this list is not all berries, unless eggplant is berry and watermelon. I don't know. Okay, so let's put that up here. And then we can see it pop up in this last one and in this one. So if I add strawberries, now you see it at the end of the list. So append will modify your original list. So if you do berries.append, everything will be saved to the same original list. There are some functions that are that don't do that. So they return a new list, but they do not modify the original one, which we'll see later on. So this is how you can append. What was your other question? How to
remove one, and how do you like pick the index you want to put strawberries in?
Yeah, so I think with append, you can say append and then choose an index, if I'm not mistaken. So let's say 1. I'm not 100% sure if that would work. No, append takes exactly 1. I think there's another function for that. So berries dot. Typically, if you do dot, it'll give you the options for that thing. So this is a list. It'll give you the options of what you can do to the list. So you can remove. So let's say remove, and then you can give it the value. So let's say I want to remove tomato. Yeah, tomato will show up in the beginning ones. So here it is. Okay. So I removed tomato. You don't see tomato in here at all anymore. Similarly, you can do an insert. So append will just append it to the end of the list. If you do insert, you can choose the index. So this also gives you like a guide of what values is allowed to go inside. So you can choose the index. So let's say I want to append, insert this into the first index. And I want to call this some berry That's not how you spell berry. Okay. And let's see. So we inserted some berry and then we printed out the 0th index. And you see here, earlier it was grape because that was the first one, and now it's some berry. Let's see what else we can show you. Clear will clear the entire list. Don't really want to do that. Copy, you can, it gives you a copy of it, so you can save it into a different variable. Count, let's see what count does. Returns a number of occurrences of a value. So if you have multiple of something, you can, like if you had 2 tomatoes in here and you wanted to see how many tomatoes, you can do this. Let's say I'm going to append tomato. So this count, if I print it, it should give me 2. There we go. Oh, I forgot to look at questions. Okay. And yeah, throughout the lesson, if you have questions, just do like the little raise hand button, and then we'll keep answering them. Okay. What else? Queries dot extend. So extend will take a list and it pretty much smushes 2 lists into one bigger list. And yeah, pop removes the last element. Remove will allow you to choose an index. So here's the description. Remove first occurrence of a value. Reverse will allow you to reverse the entire list backwards. Sort, it'll sort in ascending order. And it sorts in place. So if you do berries.sort, it's not going to return a new list, but instead it's going to sort the entire list alphabetically. So if I do this, now our order is different. So we have watermelon last, the 2 tomatoes next to each other, some berry, and so on. Any questions about lists? Oh, Mason, yeah. Pop. I forgot that it does take, it can take an index. So if you don't put anything, it'll take off the last one. But if you put a certain index, like 3, it'll remove the third index. Awesome. Any questions? I'm gonna comment these out now. Okay. All right. Let's talk about tuples. So a tuple in Python is basically like a list, but it's defined with parentheses instead of brackets. So if we said, let's say, days of, I'm gonna copy this over because it's already written out for me. So if we say days of the week, so instead of the square brackets that we had up here, we're doing parentheses. So unlike the list, a tuple is immutable. So you cannot really add, remove, modify anything in the list. So I guess it's kind of equivalent to saying like doing a const in JavaScript. So you're not able to do anything with the list except use it, iterate through it, and stuff like that. You should use the tuple if you want to make sure that the items never change. Like if you want to store, like here, the 7 days of the week, then you would want to, what is it called? You would want to store it in a tuple because tuples never change. And the days of the week will never change, hopefully. And yeah, that's pretty much it. And you can access the values. Like we can in an array. So just through this. There we go. Let me just comment this out. So you can do that. You can do the same like splicing syntax as well. Yeah. Questions on tuples? All right, we're breezing through these. So the next one we're going to talk about is probably my favorite, dictionaries. Just keep it consistent. So dictionaries are very similar to JavaScript objects. So if I wanted to say my dictionary, you can create it using the curly braces, the same way that you do with a JavaScript object. If you want to define your items, though, you would have to say, so it's a key value pair that's inside. You actually have to put or specify that it's a string. So you can't just have key like this in here, like JavaScript. So you have to have it as a string. So key, and then value. And to print this value, I can access it through the key. So I can say my dictionary, square brackets, key. And then it should print out when I print. There you go. So we got value. So let's see, we have an example here. So typically, because it's a key value pair, you would want to use a dictionary to store information that is a bit more complex and that will allow you to access things easier. So let's say I'm working with data that, like I'm creating an app that has users, and each user is a person, and each person has, let's say, a name, an age, and a job. You'd probably want to put this in an object or, in a dictionary, because that will allow you to access each person's information more easily. So let's say this person has all of these. If I want to access his age or name or job, I can use the same square bracket syntax. And the nice thing is, if you have a list, so you can put these dictionaries in a list. So we have a list, and each item of this list is a dictionary. So that way you can access, you can hold information more easily, and then you can loop through this every item in this list and access each person's information using the keys. So how can I access, let's say, this person's age? How can I print that out? So people
index 2, index age.
Index 2, age, and index 2, which person is that going to give me?
Carol.
Yep. And if I wanted to get this one, it'd be 1. So there we go. So people is a list. So that's why we need to access the item through the index, and then this entire thing will evaluate to this dictionary. So then we can access what's inside of that dictionary using this. So you can just kind of chain them. And you can do the same if they were even more nested. So even if you had like this age or this job was a dictionary or a list. So this could be like a list of all the jobs that this person could have had. Then if you wanted to, you would say job, and then let's say you wanted the first job that they had, then you would do 0 if this was that. Any questions on this?
Is there a dot notation in Python for this?
For dictionaries, no.
Oh, then.
So people dot, oh, sorry, people is a list. So I think the other, yeah, it was Jeff. So a dictionary has other types of functions, but you can't use it to access the actual instances. So within the dictionary, we have clear, so similar. Get will allow you to get so get is similar to the square bracket notation here. So instead of using square brackets, you can put job inside of get. So do this, and that will get you the value. You also have items, which will give you all of the items. So I'm going to print this out. So when I printed out the items, it gives you a list of tuples. So here, and this allows you to, like, when you're iterating through it in a loop, and we'll see the example of iterating through this in a loop in a bit.
Sorry, what does the last code print? Like print people one?
This one, let's do it. So I don't have an item in here, so I'll just say this one is some job. So people at 1, oh, because, so this is also something that I forgot to mention about the strings. If you have a string and you use, so let's go back up to the string example. So let's say I have the string with my name. If I wanted to access just one letter of this, I could say name with the square brackets and give it the index of which letter I want. So let's say I want the third index. I could print this out. And it printed the n, which is the third index. I think you can also do the splicing. So yeah, there we go. So similar to the list, it gives you the characters up until the third character. So technically, a string is a list of characters, if you want to think of it that way. So down here, the reason why, so people at 1 will access this person, right? And then at job, we'll access this value. And this value, since it's only a string, it's going to return the first element in that string. So it returned a D. If I change this to the first person, this person's job item is a list. So it'll return the first item in that list. So if I print this out, now I see some job was printed because this is the first item in the list of jobs. Did that make sense? Yeah.
Yes. And is there a way to refer to job like in a different way? Like we know that it's like insert in the dictionary instead of typing job?
Let's see, was there an index? I think with dictionaries, you have to. Yeah, you can only access it through having the key. And if you don't have the key, then you can just loop through all the items of that dictionary to find the job that you, or the thing that you want.
Okay.
Awesome. Any other questions? All right. So if you've noticed, when I'm writing code, I'm just kind of writing like there's no semicolons, there's no curly braces to like, well, we haven't done loops yet, so you wouldn't have noticed. But let's talk about functions. So with functions, when you want to define a function, you have to use the DEF keyword. So this will allow you to signal that this is a function. So if I want to do define 5, and this is the syntax. So it's the name of the function, and then you have an empty parentheses. Just a pair of parentheses in case you want to add variables, and then a colon. And you see there's still a red squiggly because you need to have something inside of the function to not have it give an error. So if you don't want to do anything yet, if you don't have any code that you want to write, you could either do a return, or you can do this pass keyword. This pass keyword was added just basically to allow you to scaffold out functions and not really have to return or do anything. That's actually maybe not the main purpose of it, but it is often used that way. So let's say in my function, I would like to return 5. And instead of having curly braces, Python relies on indentation. So anything after the colon has to be indented. So that means that this block of code, whatever is under here that is indented, falls within this definition. So we're defining a function, and then everything below it is here. So if I wanted to do whatever operations here, stuff like that, write code, it'll all be indented. So for now, this one is just here. If I want to call this function, I just call it normally. So give me 5. And I don't have any parameters that are needed in here. So I just call it like this. And this will end up returning 5. So I might want to print this out. Indents have to be 4 spaces. I think so. I think, yeah, I know, yeah, VS Code does. I think they just have to be consistent. Yeah, like what Nick is saying, they have to be consistent throughout your entire file. So if you're using 2 spaces to indent somewhere, it all has to be the same. But if you're using something like VS Code, you can just do tab, and that will be enough. There this. So now if I run Python, there we go, we get 5. Yeah, so Python is very white space sensitive. So if I added so here it doesn't care that I added the 1 space, but if I had something here that is indented 4 spaces and then this one was indented 5, it's causing me an issue. So it just needs to be at the same level. And if I added a space here and a space here, then it would still be accurate. It would still work. let's see. Okay. Let's define a function with one parameter. So let's say add 1. And then here we can just take a number. And we can just return num plus 1. That's all we want the function to do. So if we print add 1 with, let's say 6, it should print out 7. There we go, printed out 7. If you add multiple variables, so I'm just gonna grab this example. If you add multiple variables, the order of the variables will matter. So if I call this function describe varies, that takes in a number and a color, and it just says I have 3 something varies. It will, so this one's already printing, I don't need to print it out here. So if I print it out, I have 3 blueberries. But if I swap these two, it will matter. You guys probably already know this because you've coded before. But yeah, so it swapped the two, which is something you need to pay attention to when you're writing the code. So if the variables are written like this, you have to care about the order, but there's a way to define it where you don't actually have to care about the order. So the way I can do that is to give this variable like a default value. So let's say n equals 1, color equals blue. So now, if I want to send this in, let's see what happens. So it still works if you do it in the correct order. Let's say I wanted to send in blue first. So I wanted to say this is color. So color equals blue, let's say red. And then, oops, n equals 4. And if I print it out, I have 4 red berries. If I remove one of these, if I only send in color equals red, it'll default to 1 and it'll still send in the red, which will overwrite the blue. So this is how you can allow, let's say you have, you just have like a bunch of variables that are not in order and you don't remember or care about the order. So then you can just define your function like this. You can send it in any order as long as you have, as long as you're saying which variable this thing is going to be assigned to. Okay. So there's another way to send in variables. You can say, I'm just going to copy this over. So another way to define a function that takes in any type of argument, so any number of arguments, you can put a star before the argument name. So this can be named whatever. And then we can say print, just print args. And to call it, let's say we're gonna send in a bunch of names. So in here, we sent in 3 names as variables. And there we go. It just prints them all out. So this is to specify an unknown number of arguments. There's another version where you can send in an unknown number of keyword arguments. And keyword arguments mean this. So keyword arguments, that means there's a keyword that is assigned to an argument. So if we say, what am I? And to do the keyword arguments, you put 2 stars. So keyword arguments. And then we can loop through it. So keyword arg in Keywordargs. We will talk a little bit more about these loops. Then we can print this. Okay. So what this function is doing is it's grabbing whatever comes in, however many keyword arguments there are, and it comes in, if I'm not mistaken, as a dictionary. I will need to confirm that, so we can just print the type of Keywordargs. So that way we'll see what type comes in. And then we're looping through. So for this is just a variable name. I can call it anything. I can literally call it anything. So for anything in Keywordargs, similar to JavaScript, if you're looping through an object or a dictionary, you will get the keys. So this is going to be the key, and you can access the value through the square bracket notation. So if I named my key anything, my anything is this dictionary at anything. So this is the key, this is the value. If I call the function who am I can send in a bunch of variables. So name, age, I'm not actually looking. I'm an instructor. Okay, so if I print this out, so it did send it in as a dictionary. So it takes all of these specified keyword arguments, it squishes them into a dictionary, and then it sends it into the function when you have these 2 stars. And then you're looping through the function, grabbing the key, and then for each item, so for each one of these, it prints out the key, so name, and then the value of it. Any questions?
I'm sorry, what exactly is the double asterisk doing?
The double asterisk is allowing you to send in as many keyword arguments into the function. So that is the notation to be able to define a function that takes in an unspecified number of keyword arguments. So I think we had, let's say this person here. I want to test something out. So if we have this dictionary here, and instead of this, I'm going to send in chef. Let's see if that actually works. Okay. I'm trying to remember how to, I think I have to put a star next to it. Ah, there we go. It worked. So if you have a dictionary and you do the stars, it pretty much takes that dictionary, because this one is going to compress it into a dictionary, but when you're calling it, you can send in a dictionary with the 2 stars as well, and it takes everything in here and makes them keyword arguments. So that's a pretty good functionality if you have dictionaries of information that you want to send into a function, and you know that the information is going to be the same, but you don't want to, like, maybe this doesn't have just 3 items, it has like 7, and you don't want to write every single variable name out here, then you can just do it like this, and it compresses it, it keeps it into a dictionary form that you can use easily in your function. Questions? No? Okay. Yeah, if no one has any questions, we can take a little bit of a break. We can actually, let me see. So we have if statements, loops, and methods. Yeah, we don't have too much left to cover. So let's take a 10-minute, let's come back at 10:30, so a little more than 10. And think of anything that you want to see in Python, any questions that you have, and then we can look into it at the end of the lesson as well. See you guys soon.